For as long as human beings have existed, there has been one question that has never truly left us. What came before us? Every civilization, no matter how isolated or advanced, eventually looked upward and wondered where everything began. The stars inspired myths long before they inspired science. They became gods, guides, calendars, and symbols of eternity. Yet behind every story was the same quiet curiosity. Somewhere beyond those distant lights, hidden in the darkness, there had to be an answer. For thousands of years, that answer remained hopelessly out of reach. The night sky appeared permanent. Every generation inherited almost exactly the same stars as the one before it. The constellations changed so slowly that they seemed eternal. To the human eye, the universe looked complete, as though everything worth seeing had already revealed itself. There was little reason to believe that the darkness concealed anything fundamentally different beyond the reach of our vision. The limitation was easy to mistake for reality itself. When we cannot see beyond a certain point, we naturally begin to believe there is nothing beyond it. History is full of such assumptions. There was a time when oceans appeared endless because no one had crossed them. Mountains marked the edges of maps simply because no traveler had walked farther. Entire civilizations believed the world ended where their knowledge did, not because they lacked imagination, but because every tool available to them insisted that it was true. The universe has always played the same trick on us. For centuries, every telescope humanity built seemed to reveal another layer of the cosmos. Galileo transformed tiny points of light into worlds. Larger telescopes uncovered galaxies beyond our own. More powerful instruments exposed nebulae, clusters of stars, and structures so immense that they reshaped our understanding of reality. Each generation believed it had finally reached the limits of what could be known, only for the next generation to discover that the horizon had quietly moved once again. Yet there remained one boundary that appeared almost impossible to cross. It was not a wall hidden somewhere in space. It was time itself. Every telescope, no matter how sophisticated, depends on one simple thing. It collects light, nothing more. Mirrors become larger. Cameras become more sensitive. Instruments become more precise. But every discovery ultimately relies on the arrival of tiny particles of light that have spent years, centuries, or billions of years traveling across the universe. This creates an extraordinary consequence. Seeing farther has never simply meant seeing more distant places. It has always meant seeing older moments. Distance and time become inseparable because light refuses to travel instantly. Every additional kilometer pushes observation slightly farther into the past. On Earth, those delays are too small to matter. Across the solar system, they become measurable. Between stars, they become impossible to ignore. Across galaxies, they transform astronomy into something no one could have imagined when humanity first looked toward the heavens. It becomes history. Not history written in books or carved into stone, but history preserved by the universe itself. Every photon carries evidence of a moment that no longer exists. Long before telescopes could reveal this truth, the universe had already chosen how it would tell its story. It would never allow anyone to witness events as they happened. Every observer, no matter where they stood, would always arrive late. Reality itself imposed that rule. Information could never outrun light, and light could never outrun time. It is difficult to appreciate just how remarkable this is because our everyday lives rarely expose us to such enormous distances. We experience the world as though everything unfolds simultaneously. Someone speaks, and we hear the words immediately. Lightning flashes across the horizon, and only then do we notice the delay before thunder arrives. That brief pause reminds us that even sound has limits, yet light moves so extraordinarily fast that it tricks us into believing those limits no longer exist. The cosmos quietly reminds us otherwise. Imagine opening a book whose pages are scattered across billions of years. The first page was written shortly after the universe came into existence. The last page has not yet been written at all. Every time we point a telescope toward the sky, we are not choosing where to look. We are choosing which page to read. Nearby stars tell relatively recent chapters. Distant galaxies reveal stories unimaginably older. Somewhere beyond them lies light that began its journey when the universe itself was still young, before planets, before oceans, before life had ever appeared anywhere we know. For decades, astronomers knew those pages existed. The problem was that they remained unreadable. Not because they were hidden, but because the light carrying them had become almost impossibly faint. During its journey across the expanding universe, that ancient light had been stretched, weakened, and shifted into wavelengths invisible to human eyes. It continued traveling faithfully through space, carrying the earliest chapters of cosmic history, yet every telescope humanity possessed lacked the sensitivity required to receive it. This limitation shaped astronomy for generations. Scientists built larger observatories on mountaintops, launched telescopes above Earth's atmosphere, and developed increasingly sophisticated instruments, each one extending humanity's vision a little farther into the past. Every breakthrough revealed another layer of history, but the beginning remained frustratingly distant, like a forgotten memory that could almost be recalled but never fully reached. It became clear that solving this problem would require something fundamentally different. Not merely a bigger telescope, a telescope designed for a different universe. One that could see light our own eyes never evolved to perceive. One that could detect whispers instead of voices. One that would patiently wait for photons that had spent more than 13 billion years crossing an expanding cosmos simply for the chance to be observed. That machine would eventually become known as the James Webb Space Telescope. It is often introduced as the most powerful telescope ever built, and while that description is technically correct, it somehow feels incomplete. Power alone does not explain why James Webb matters. Larger mirrors and sharper images are only part of the story. Its greatest achievement is far more profound. For the first time in human history, we built an instrument capable of reaching so deeply into the past that it could begin to witness the earliest chapters of the universe itself, not by traveling through time, but by waiting for time to arrive. There is something almost paradoxical about the way we imagine progress. We often think that every new scientific instrument simply reveals more of the same world. A stronger microscope allows us to see smaller organisms. A more powerful telescope allows us to see more distant stars. Progress feels linear, as though every improvement merely extends the range of our vision a little farther than before. James Webb reminds us that this is not always how discovery works. Sometimes moving just a little farther changes the nature of what we are looking at entirely. Imagine standing on a mountain at sunrise. At first, the horizon appears empty. As the sun climbs higher, more of the landscape slowly comes into view. Villages emerge from the darkness. Rivers begin reflecting the light. Forests reveal shapes that had been hidden only moments before. The world itself has not changed. Only your ability to see it has. Astronomy often feels exactly the same. For decades, scientists believed they had assembled a reasonably complete picture of how the early universe evolved. It was not a perfect picture. Science never claims perfection, but it was supported by decades of observation. Galaxies were expected to appear gradually. Stars would need time to form. Structure would emerge slowly from simplicity, just as ripples gradually spread across the surface of a quiet lake. It was a story that made sense. Then James Webb began opening pages that had never been read before. Some of the earliest galaxies it observed appeared surprisingly mature. They seemed brighter, larger, and more structured than many astronomers had expected to find so soon after the birth of the universe. These discoveries did not overturn everything we knew, as dramatic headlines sometimes suggested, but they did something far more valuable. They forced scientists to ask better questions. That is how science truly moves forward. Not by protecting old ideas, not by celebrating every new observation as a revolution, but by allowing reality to speak for itself, even when reality refuses to match our expectations. Perhaps that is James Webb's greatest contribution. It did not give humanity all the answers. It revealed how many questions were still waiting. There is something deeply humbling about that thought. The more powerful our instruments become, the less complete our knowledge begins to feel. Every generation of astronomers has experienced the same pattern. A discovery closes one mystery while quietly opening 5 more. Knowledge does not eliminate wonder, it expands it. The universe seems almost reluctant to become simple. Every answer uncovers another layer beneath it, as though reality is inviting us to continue asking rather than encouraging us to stop. James Webb has become one of the clearest examples of this endless conversation between humanity and the cosmos. Its images are breathtaking not simply because they are beautiful, but because every point of light represents information that has traveled almost incomprehensible distances across space and time. Those photons left their galaxies long before Earth became the planet we recognize today. They crossed billions of years without memory, intention, or purpose. They simply followed the laws of physics until, one day, they encountered a mirror built by a civilization that had only recently learned to leave its own planet. It is difficult not to see something poetic in that. The universe spent billions of years writing its history long before there was anyone capable of reading it. Only now has a tiny species living on an ordinary planet around an ordinary star begun to decipher the opening chapters. When we look at one of James Webb's famous images, it is tempting to admire its colors, its astonishing detail, or the elegant spiral arms of distant galaxies. Yet those colors are only translations. They are representations created to help human eyes interpret wavelengths that would otherwise remain invisible. The true achievement lies far beyond aesthetics. Every image is evidence that information can survive almost unimaginable spans of time, long after stars have changed, long after galaxies have evolved, long after civilizations rise and disappear. The light remains, traveling, patiently carrying history forward. In many ways, astronomy is unlike any other science because it allows us to witness events that no experiment could ever recreate. No laboratory can reproduce the birth of the first galaxies. No simulation, no matter how sophisticated, can replace observing the original light itself. Computers help us understand what may have happened, but telescopes allow us to witness what actually happened. That distinction matters. Science is strongest when observation leads the way. James Webb does not ask the universe to fit our theories. It asks the universe to tell its own story. Perhaps that is why its discoveries have captured the imagination of people far beyond the scientific community. Even those with little interest in astronomy instinctively understand that something extraordinary is taking place. We are not simply building better machines. We are extending the memory of our species. Every generation inherits a slightly larger picture of reality than the one before it, adding new pages to humanity's understanding of existence. Somewhere beyond the reach of today's telescopes, there is still older light making its silent journey across the cosmos. It has not arrived yet. Perhaps it will reach Earth centuries from now. Perhaps it will be collected by instruments that have not even been imagined. Future generations may look back at James Webb the way we now look back at Galileo's telescope, not as the final step, but as the moment everything began to change. That may be the most inspiring lesson hidden within this remarkable machine. Knowledge has no finish line. Every horizon we reach simply reveals another beyond it. For thousands of years, humanity looked toward the stars searching for answers. Today, we still do. The only difference is that our questions have become deeper, and perhaps they always will, because the universe is not a puzzle waiting to be solved once and for all. It is a story that continues to unfold with every new beam of light that reaches us. James Webb did not merely show us distant galaxies. It reminded us that every photon crossing the darkness is carrying a fragment of history. And for the first time in human history, we have built an instrument capable of listening to some of the oldest stories the universe has ever told. Perhaps one day, humanity will build a telescope even more powerful than James Webb. One that will see farther, deeper, and closer to the very beginning of everything we know. And when that day comes, it won't mean that James Webb was replaced. It will mean that another page of the universe has finally become readable. Because every generation inherits the curiosity of those who came before it. Every discovery becomes the foundation for the next question. And every beam of ancient light that reaches us reminds us that the universe has been telling its story all along. We simply needed to learn how to listen. Thank you for spending these moments with me. If you enjoy exploring the ideas that reshape the way we see reality, I'd be honored to have you here for the next journey. Until our next thought.